widespread GPS outage and you need to shoot an instrument approach? What if you lose both your GPS receivers and you need to shoot an instrument approach? Welcome to another real-world SF-50 flying video. This one is titled VOR Approaches Without GPS. Hello, I'm David Weeks. I've been flying professionally for over 50 years, starting as a CFI, then as a charter pilot in light twins. I spent time as an air ambulance pilot in a Swearingen Metro and worked as a demonstration pilot for the Learjet factory. I had a 35-year airline career flying the 737-200 and 300, the A320 series, and I retired as a Boeing 787 captain. I'm also a current CFII. I've got over 650 hours in the SF-50, and I'd like to share my SF-50 experiences with you. Now, there may be other YouTube channels that have glitzier production values than this one. I like to spend my time writing and teaching about the SF-50 and not doing post-production work. So just imagine that this video is like a hangar chat session between friends. Let me be clear that this video is not flight instruction. The Cirrus SF-50 airplane flight manual is always controlling. What are the odds of not having GPS at the worst possible time when you have to do an instrument approach to land? I'm the first to say that the chances of these things happening is slim, but it's worth thinking about so you aren't caught totally unawares and clueless if all the holes in the Swiss cheese line up and you have to find an airport to land in instrument conditions without GPS. We all know that nobody plans to do a cross-country flight in Vision Jet using VOR navigation. That's probably one reason that few, if any, people do the 30-day VOR receiver check outlined in FAR 91.171, as they are not planning on using a VOR for navigation. I sometimes do it, but I must admit that I rarely get it done every 30 days. Now, we all plan to navigate with GPS, and many flights use GPS from takeoff to touchdown if you're going to do a GPS approach. GPS is an acceptable substitute for VOR and DME information, as outlined in the Aeronautical Information Manual, Chapter 1-2-3. But I want to focus on what happens when you lose GPS in the en route portion of the flight and decide that for whatever reason you need to land. This could result from a failure of your airplane's GPS receivers or widespread GPS jamming. I'm not going to spend time discussing the numerous system failures and CAS messages and alerts that do result from a loss of GPS, but a partial list of what you lose includes synthetic vision on the PFD, wind vectors on the PFD, DME information, ground speed information on the PFD, the stick shaker, emergency auto land, and surface watch. Here's some pictures of the GPS receiver page that I took during a recent GPS outage near the White Sands Missile Range in early May 2025, and the 2 pages of alerts that came up on GTC1. Now, none of the systems issues that happens when GPS fails are serious. Aircraft control is not affected, nor is communication. The main problem is that our usual method of navigation is disrupted. Remember, aviate, navigate, then communicate. Keep flying the airplane. If you are in nav mode, as is usually the case in cruise flight, press the heading knob to sync the heading bug to the current aircraft heading and then engage heading mode on the autopilot. Then tell ATC that you've lost GPS. Now first, everybody needs a basic understanding of the VOR MON or MON network. MON stands for Minimum Operational Network. When the FAA began the process of decommissioning VORs a number of years ago, it created the MON system. The VOR Minimum Operational Network ensures that within 100 nautical miles of any location in the continental United States, there is at least one airport with a suitable instrument approach procedure, an ILS or VOR, that can be flown without relying on GPS, DME, or an ADF. Now, note that a DME signal is not included. That's good for us as the majority of SF-50s do not have DME installed as standard equipment. Now, yours might if it was ordered by a European customer. Now, how do you know which airports are served by MON VORs? If you use government in route charts, it's easy. Look for a green MON above the airport name. If you use Jepson charts, it's quite a bit harder as Jepson does not display MON served airports. You have to go to the chart supplement, which lists MON airports by state, to find them. Now, ForeFlight users can download the chart supplement, and you may wish to make a habit of this as you probably won't be able to get the chart supplement while airborne. But if in doubt, ask ATC, and the controller should know which airports near you have MON approaches. Don't forget, radio calls are free. Now, since many more pilots are comfortable shooting an ILS approach, let's talk about the other type of MON approach, the dreaded green needles VOR approach. I will bet good money that it's been a very, very long time since you've done a green needles VOR approach. By green needles, we all know that means only raw data VOR, no DME information, and no GPS backed up with the VOR bearing displayed on the PFD. Let's look at the VOR 11 approach for Winslow, Arizona, KINW. Now, I know the plate says VOR or GPS, but let's ignore the GPS and walk through shooting this one using green needles. Assume you're flying from Dalhart, Texas, KDHD, direct to Las Vegas, Nevada, KLAS, and you lost GPS due to widespread GPS jamming when about 70 miles north of Winslow at flight level 300. You tell ATC of the GPS loss and inquire about close airports with MON approaches. ATC says that GPS appears to be out all over the west and southwest, that Winslow is nearby, and the Winslow weather is 800 broken and 5 miles visibility with calm winds. Flagstaff also has decent weather, but the ILS is NOTAM'd out of service, the controller says. You decide to divert to Winslow. You tell ATC you want to divert to Winslow and request direct Winslow and a lower altitude. ATC replies that you are cleared direct Winslow and are cleared for the VOR 11 approach and maintain 9,500 feet MSL until the Winslow VOR. Now, the controller also says there is no radar coverage below 11,000 feet due to a radar outage. Now, if the controller does not give you the Winslow NOTAMs, ask for them. Remember, ATC is a resource and use it to reduce your workload. Now, just think back to how you learned to do VOR approaches in the six-pack Cessna 172 when you were an instrument student, and you'll be fine. It's easy peasy, right? Okay, I strongly recommend using the autopilot for the balance of the flight. Early on, you'll be dealing with CAS and alert messages and system failure related to the loss of GPS, so don't add to that workload by hand flying. You can ask the controller for a heading to the Winslow VOR to get started, but then you're going to need to tune Winslow in Nav1, and I'm assuming that everybody can do that. Confirm the identifier on the PFD. Next, select VOR on bearing 1. That will change the CDI to green, indicating that you are working with the VOR signal on the HSI. Now, if you push the upper knob on GTC1, that should automatically set the desired course to go direct to the Winslow VOR. Also, center the CDI. Now, you can fly direct Winslow. Push nav, and the autopilot will track that course to Winslow. Confirm nav on the scoreboard, and let ATC know that you are now navigating on your own. Okay, how far are we from Winslow? It wasn't on the planned route, and we are no longer with a GPS position. Since you have no DME from Winslow and no GPS, just ask ATC how far you are from the Winslow VOR so you can plan your descent. You're still in radar contact, so there's no need to start doing position fixes using VOR cross bearings, and radio calls are free. ATC says you're about 70 miles north of Winslow. Now, if you're at flight level 300 and need to cross the VOR at or above 9,500 feet, you have 20,000 500 feet to descend. Now, rather than using vertical speed to figure the descent, I like to figure my descents at 2.5 to 1. I have 20,500 feet to lose, so I multiply 20.5 times 2.5. That result is 51.25, and I'm going to round that to 52 miles. I would ask ATC to tell me when I'm 60 miles out, so I have a little extra wiggle room to spare. You do not want to be higher than the cleared 9,500 feet when crossing Winslow. And again, asking ATC for help is not cheating. It's using all the available resources you can muster. Now, with no DME, you cannot do a VNAV descent, so consider using vertical speed to manage the rate of descent. Planning ahead, make sure you level at 9,500 as instructed and are back to 120 knots or slower with flaps 50% before you get to Winslow. Ask the controller your distance to the VOR before you get to 1,000 on the descent due to the low-level radar outage. In the descent, finish any incomplete checklist items for the various CAS messages related to the loss of GPS. Then recheck the current Winslow weather. You should be close enough to get the ASOS broadcast for weather on COM2. Do the descent checklist. Then brief the approach. And remember, you do not have DME. First, how are you going to begin the approach? There are 3 initial approach fixes, but you're not going to be using the feeder route from the Flagstaff VOR, and the DME arc is on the wrong side of the airport from where you were approaching. Anyways, even if you wanted to, you could not fly the DME arc as you don't have DME. We are going to have to do a procedure turn. And yes, by the way, Captain, how long has it been since you did a full procedure turn? One critical briefing item is that there's a turn after you cross the Winslow VOR final approach fix. The inbound course to the VOR is 098, but the outbound from the VOR to the final approach course is 106 degrees, an 8-degree right turn. If you don't turn the upper knob on GTC-1 to reflect the 106 outbound course, you're going to be flying the 098 outbound, and that will take you well to the north of the runway. Also, you need to determine the time to the missed approach point as you don't have DME. So, just like in the Cessna 172, determine your ground speed and use the table to get the time to the missed approach point. If you fly the final at the Cirrus recommended VREF plus 10, it'll be probably indicating about 95 indicated, or perhaps a bit less. Since the Winslow Airport elevation is just under 5,000 feet MSL, you can guesstimate your true airspeed to be about 100 knots or so. This puts us in Category B. The table says that the time to the missed approach point is 2 minutes, 17 seconds. Now, if you're really sharp today, you can set the PFD timer ahead of time to count down from 2 minutes, 17 seconds and have it ready to go. Now, complete the approach checklist. And keeping in mind for procedure turn, immediately after seeing station passage on the Winslow VOR, begin your right turn to intercept the outbound leg. You need to be slow before getting to Winslow and begin the turn to intercept the 278 radial outbound as soon as you pass Winslow. We're on green needles, so after station passage, you have to set the 278 outbound course by turning the upper knob on GTC-1. There's no GPS, so the course won't set itself. Once you're on the 278 radial outbound, briskly descend to the 7,000-foot procedure turn altitude. Stay at or below 120 knots indicated. You can use nav mode to track the radial outbound. If you're feeling good, preset the heading bug to the 323 heading for the procedure turn. Broadcast your position and intentions over Unicom. Now, with no DME, you have to estimate your ground speed to make sure you stay within the 10-mile limitation for the procedure turn. With no DME, we have to estimate our distance from the VOR. So if you assume 120 knot ground speed, that's 2 miles per minute, so you could fly outbound for 5 minutes. Recall that 5 minutes is not from when you start the procedure turn, but that you can't be flying outbound for more than 5 minutes, and that includes the 180-degree turn on the procedure turn. So you should probably begin the right turn to the 323 heading after 3.5 minutes. Choose heading mode and set or confirm the 323 heading for the procedure turn. Fly that heading for 30 seconds and then do the left 180-degree turn to the 143 heading that will intercept the inbound course to Winslow. When you're on the 143 heading, set the 098 inbound course using the upper knob on GTC1. Now we've been cleared for the approach, so press nav on the autopilot control panel. Well, why not push approach APR? We're doing a VOR approach, and since there's no GPS, there's going to be no advisory glide path, and that's why we push nav. Confirm nav is armed in white on the scoreboard. So on the little jet turns to capture the inbound course, descend using vertical speed to 6,200 feet. When the autopilot is captured 6,200 feet, is confirmed by seeing Alt in green on the scoreboard. Set the altitude selector to the MDA of 5340. Now, normally Cirrus says to go gear down and flaps 100%, or as required, when we are 1 to 2 nautical miles from the final approach fix. But we have no DME. I would configure as soon as you've captured the inbound course. Go gear down, flaps 100% or as required, and slow to VREF plus 10. The power is about 35 to 40% or as required. Broadcast your position and intentions over Unicom. Do you remember the 5 T's acronym that you no doubt learned as an instrument student? This acronym is especially useful right now. Time, turn, twist, throttle, and talk. Time. Start the timer on the PFD when you get station passage. If you've already had it to count down, that's great. If not, start the timer and watch it count up to 2 minutes, 17 seconds. Turn and twist. Now this is important. If hand flying, and hopefully you are on the autopilot, turn to 106 degrees for the outbound leg, adjusted as needed for wind correction, and then set the 106-degree outbound course. But hopefully we're on autopilot, so just turn the upper knob on GTC1 to set the 106-degree outbound course, and the autopilot will make the turn. Confirm on the scoreboard that the autopilot is still in nav mode. Throttle. Now, I recommend using vertical speed to descend at 800 feet per minute down to the MDA. Adjust the throttle as needed to maintain VREF plus 10. Now we have 860 feet to lose from the final approach fix altitude of 6,200 to get to the MDA of 5340. Descending at 800 feet per minute means we get there in just over 1 minute. Now that leaves us plenty of time to stabilize the little jet in level flight at VREF plus 10 and look for the runway, the approach lights, or the runway environment. As you no doubt briefed in the approach briefing, there are REILs and a VASI on the left side of the runway. Talk. Broadcast your position and intentions over Unicom. When you level off at the MDA is confirmed by seeing Alt in green on the scoreboard, set the missed approach altitude in the altitude selector. Now, unfortunately, there is no easy way to determine a VDP, or a visual descent point, on this approach. But with the time to the missed approach point of 2 minutes, 17 seconds, I would personally become doubtful of successfully completing the approach if I did not see the runway or REIL by about 1 minute, 50 seconds. Now, technically, you do not have to begin the missed approach until the 2 minutes, 17 seconds has elapsed. But make sure you understand that you cannot make a stabilized approach down from the MDA if you see the runway, say, 1/4 of a mile away. Now, assuming you do see the runway in time to begin a stabilized descent, click the autopilot disconnect button to disconnect the autopilot and auto throttle, descend, and land. Now, if you can't reach ATC on the ground to cancel your flight plan, call them on the phone when safely parked at the FBO. And by the way, there's a nice little Mexican restaurant right next to the FBO. Oh no, what if there's no visual contact in time to make a safe landing? Do the go around as usual, press the toga button on the throttle, confirm that the auto throttle sets toga thrust, or set it manually if your aircraft does not have auto throttle. Pitch to the command bars, set or confirm, flaps 50%, Confirm a positive rate of climb and then select gear up. Now, above 400 feet AGL, we would normally press nav and fly the missed approach. But with no GPS, the G3000 can't fly the turn back to Winslow as usual. But you can press the upper knob on GTC1 to center the CDI on the direct course to the VOR. That will give you a good idea, the required heading, and you can adjust your inbound course as needed when inbound. The bearing pointer on nav1 will help you make the turn. Then clean up as usual, accelerating through 115 knots indicated. Climb straight ahead to 6,000 feet, then climbing a right turn to 7,000 feet direct to the VOR and hold as published. Since you are going to be entering the hold, at least until you are back in radar contact, keep the speed back to 120 knots indicated. Do the go-around checklist. Broadcast your position and intentions over Unicom. Switch back to ATC and declare the missed approach, and ATC will ask your intentions. If you plan to hold, you'll need to set the 098 inbound course for the hold using the upper knob on GTC1. With no GPS, you need to do this yourself. This has been a quick review of the basics of how to fly a VOR approach with a full procedure turn using green needles with no GPS and no DME or GPS assistance. We've all done it as part of our IFR training, but it may have been many years, if ever, that we've done one in the SF50. With all the confusion and workload that comes with the loss of GPS, not having to freak out at doing a VOR approach makes the situation just a little bit easier to deal with. I'm David Weeks, and thanks for watching this episode of Real World SF50 Flying.